All right, 4-5 day 1. It is time to start doing some graphing, which, as always, some like, some don't. Kind of depends on you. The point we got to after section 4 was we really were starting to think about our trig ratios as functions, right? We were able to take, the trig value of any angle, any quadrant in the unit circle, or if it wasn't on the unit circle. And that's really kind of setting the table for this particular section, is to now really take the next step graphically with all 6 of our trig ratios as trig functions. Okay, anytime we say function, think of you put a number in, you get one number out. Okay, now there's 6 different trig functions to look at. We kind of group them based on their similarities. Today is just sine and cosine. Those are the only ones that we're going to look at. They're very similar. We'll get to the other 4, but we do tend to spend most of our time with these 2. Okay? Now I'm saying this is a unit circle, by the way, so every single radius here, we're saying it's 1. To start to build the sine curve, all we really need to do is look at 5 quadrant points. That'll be sufficient. And this is going to build a sine curve that is pretty likely going to look familiar. There's -1, 0, and 0, -1. Okay, those are the coordinate points there of each of those. We've talked about this a little bit, that sine values don't go above 1 or below -1. Now I'm going to graph one period. And so I'm going to split up this period into quarters. And those should look familiar because those are all of your quadrant angles. Okay? We're going to be talking radians the whole time today, by the way. All right, so keep in mind sine is always your y coordinate on the unit circle. So I start looking right here. And when our angle is 0, the sine value is 0. I head up to pi over 2, and I can see sine now takes on a value of 1 over to pi, and we're back to 0. 3 pi over 2, we bottom out at -1, and then at 2 pi, there we are back at 0. And you can kind of see the shape from these 5 points. It doesn't take much. There is one period of the sine curve. Okay, no transformations or anything. That's kind of where we're headed next, but there it is. Okay, again, these are functions that are periodic. All right, I'm only doing one period because once we go past 2 pi, this pattern that we see just repeats again and again and again. Even if we went to negative x values, that's what we would see. Let's do the very same thing down here. Okay, but now let's talk about cosine. It's going to be a pretty similar process, and honestly, you should see some pretty similar results. Okay? It's going right back to the quadrant points. Okay, if you could see these from your previous slide, you don't have to write these in again. I am, because I can't see them anymore. So I want to make sure you're clear as you're watching this which points I'm referring to. More similarities here. Not only are we going to build it from the same points, but we're also going to see this property that it can't go above 1 or below -1. And this whole idea of its period, which is how long it takes, the graph to do, one cycle before it starts to repeat, it's also based on 2 pi. Again, I want to refer to the quadrant angles. Okay. Same deal, going around this circle, except now I'm looking at the x-coordinates, because I'm talking about the cosine function. All right. The first big difference we see is the sine curve would start right at 0. Cosine is going to start up at 1. And then cosine will hit 0. And at pi, it'll bottom out at -1, then back to 0, and then it will finish where it started, up at 2 pi. And we'll see something like that. Okay? Kind of looks like the sine curve, kind of doesn't. Really all that's going on, like the big difference that you should notice, sine starts, a lot of you will think about it as right in the middle, like right halfway between -1 and 1, whereas cosine starts up at the top at 1. Okay, it's time to talk about a couple of transformations that we could do. There's really 4 of them, and the first day of lesson 5 is just going to be 2 of them. Amplitude and period length are the 2 things that we want to mess around with. All right. This number right here changes your amplitude. Okay. A couple things about it. We call it A. And if you want to relate it to some vocabulary that you're familiar with in terms of a transformation, is we would call it a vertical stretch. Okay. Remember before, our sine curve went between 1 and -1. This needs to get stretched out because it's going to go twice as high and it's going to go twice as low. Now over here, notice I'm going to base it off of the same angles. Okay, that's a really big thing, and we'll talk about it big time in the last example where we'll do one where we'll have 2 transformations going on. I'm going to show you 4 of them between the 2 days. Every transformation does one thing, all right? And these get a little bit more complex as we do multiple of them at a time, but the key is being really clear on what each transformation does, okay? Now I bring that up as I am marking, that should be pi by the way, as I'm marking the x values that I'm going to use. Notice they're the same as before. So I'm kind of setting this up to have a period of 2 pi. And I should, okay? Because A doesn't change that. A is going to stretch it vertically, but as far as how fast or how slowly the graph goes through its repeating pattern, A doesn't do anything, okay? It doesn't affect that. Now, you have the option to do this or not. I don't really care which way you go. I think it's good in your notes that you've got the comparison. So right here, this is not the function we were asked to sketch. That's good old sine of x, okay, before the transformation is going on. Okay, it's good, I think, to see that reference. Sine of 2x is going to start here, but then it's going to head all the way up to 2, back to 0, down to -2, and then back to 2 pi, and will look something like that. Goes twice as high and twice as low. Okay, here's another one. We're going to do cosine, except this one has a negative value. Okay, we'll get to that. Let's start to kind of set up our scales here. Now, we haven't really addressed the negative thing, but you probably get the sense that we need to go up to 3. we need to go down to -3. And of course, I'm going to set up one period of the graph, and notice again, without even thinking about it, I go to 2 pi, because we know that this number that affects the amplitude, it doesn't change anything in regards to period. Okay? Now, just like I did before, I'm going to do it each time in red. Here is the cosine curve. So that's the graph that we're kind of messing around with and changing. And notice that there's kind of a unique way that we, that second part of the graph doesn't look like a real good smooth curve, but that's all right, we'll leave it. You really just go off of these 5 points, where we don't necessarily do a table of values, but we want to be really clear on when we're sketching a periodic function, particularly a sine or a cosine curve, is how long is the period, how high does the graph go, and then how low does it go. Okay, from there, okay, you can kind of figure out what's going on. All right. Now we know this is going to go between 3 and -3, and you probably guessed it. It just ends up being a reflection over the x-axis. The fact that it's negative means that this cosine curve has to start at the bottom. And it will be based off of those 5 points. Okay, still goes 3 times as high and 3 times as low. It just starts opposite. Okay, it would have the same effect on the sine curve. Instead of going, the sine curve would still start in the middle, but it would go down right away instead of going up. Okay, the negative value out front, it's a reflection across the x-axis. That's always what that negative value does, and the cosine curve and the sine curve, no exception. All right, we've talked about it quite a bit. So this is the second thing that we're going to do. Okay, this whole idea of changing the graph's period. I'll give you one example to start here with the sine curve. Now this is really just going to be a rough sketch. I'm not even going to mark the points in between. It would go up and then down and then to 2 pi. Okay, really, really rough sketch. Now this next example I'm going to show you, like right off the bat, we're not going to mess around with the amplitude. So I'm going to give you one where you know you're still going between 1 and -1. Okay, that's not going to change. All right, what we want to look at is something like this. If we were to go out to 2 pi, what would we do if we had a sine curve that did something like this? In 2 pi, right there, there's 2 periods instead of 1. Okay? Now we got to change the equation. It's not just going to be sine of x, because it's clearly a different graph than sine of x. Okay? And we have this new parameter called b. Now we got to be really clear about b, because we don't want to get it confused with period length. B, which we'll refer to quite a bit, is not the period length. It will change it. If you want like a definition for, hey, what's B? It is the number of periods in 2 pi. Okay? Like if you relate it to the graph, that's actually what it means. All right? Now where B is going to go is that A goes out in front, B is in here, okay, like sine of bx. Now when you think about the definition of B, you could look at that and probably figure out that's sine of 2x, okay, because in 2 pi, it's doing 2 periods, okay? Now let's think about the period length, because that follows this formula. A common mistake is to say that, yeah, B is 2, so the new period length, that's not 2 pi, now it's 2. Well, No, it's not. So if we take that formula and we plug in b, the 2's cancel. There is your period. It's now pi. Okay, so if I marked right here, you can see at the halfway point, at pi, the graph has already done one period, and then from pi to 2 pi, it does another. Okay, so you got to be really clear. This is a big formula. Probably something come test time is going on your note card. Okay, b affects the period length, but b is not the period length. Okay, it's a big idea. Now this one's kind of interesting. All right. Now as I go to my graph to kind of get my scale ready, now watch this. Notice 1, -1. I was looking out front here for a value of a, and I didn't see anything. Okay, which means a is 1, which means the amplitude hasn't changed. Okay, we're going to do 2 graphs here to finish this lesson where we're going to change the period. This one we're not going to change the amplitude, the next one we will. All right, now on the test, this is such an important thing, I don't give you the choice not to do it. Is when you look at all like these key factors that affect this new graph, I give you a little table that you have to fill out for points before you graph them. You should get in the habit now. Like on a checkpoint quiz, you'll see what I'm talking about. So for example, this one's a little bit tough to see, but the value of b is 1/2. Okay, before you even go down to start making your graph, you will have to identify that. Okay? Same with the period length. We go off of our formula, which is 2 pi divided by 1/2, which is 4 pi. Now I'm going to go down here and I'll mark it. Okay, I want this to go out to 4 pi if I'm going to see one period of our new trig function, which is cosine of x over 2. We still go through the same pattern of just splitting it into quarters. That tends to work fairly well. Now, as always, okay, I am going to go and I'm going to do, in red, just cosine of x. Okay? Now keep in mind, the period of cosine of x is just 2 pi. There it is. Okay? Now, I have the room on here. We haven't done this with anyone yet. I could draw another period. Within 4 pi, I have the room. So I head down, bottom out at 3 pi, back up. Okay? So there's 2 periods of the cosine curve. Cosine of x over 2 is going to be a different story. Okay? Here, by the time I get to 4 pi, I should only see 1. It should bottom out halfway in between at 2 pi, and then hit the zeros at pi and 3 pi. Okay? But I already identified with this graph, its period is 4 pi. So in the scale that I have drawn for my x values, I should see 1 for this new graph. And there it is. Okay? Now remember the value of a b is 1/2. Literally what that means is it's how many periods are going to happen in 2 pi. Okay? If you look at the green graph, by the time it gets to 2 pi, it hasn't even completed a period. It's only done 1/2 of one. Just like the value of b states that it will. All right, last example of the lesson. Okay? Eventually we'll get to a point with these where we should be able to handle 3, occasionally 4 transformations going on. This is our first look at 2 of them. And this is where it gets really important, that you have to remember what does what. Okay, and this is why your quizzes and tests will give you this table where you need to go through, right? For this one, it would have 3 things. Before you even start to graph, you have to tell me A, you have to tell me B, and you need to tell me the period length. Okay? From what I've seen in the past, if you're not clear on what those values are, your attempts to create a good graph are going to be so unsuccessful, I'm not even going to let you try. Okay? You can do it on your homework, but on a quiz or a test, you got to do it this way. So I want you to identify right off the bat that, hey, A is 3. So I'm going over to make my sketch here, and I'm like, all right, 1, 2, 3. This is going to go up to 3. Down to -3. B is 2. And that leads me to my period length formula, which tells me 1 period of this graph is going to be pi. Now I'm going to go out to 2 pi, because you might be like, hey, why wouldn't you just then go out to pi? You could. Remember, I'm going to put the original sine curve on here as well, and I need 2 pi to see all of that. And I'll still just split it up into quarters. Okay. As always in red, sticking with the same theme I have. Okay, sine would start at 0, head up to 1, back to 0, down to -1, and then back to 0. There it is. Okay, been a while since we've seen the sine curve. We started with it, and then I think the last 2 examples that we've done have both been with the cosine curve. But here we are, back to the sine curve. Okay, now in green, I'm going for this brand new graph. Think about where it starts first of all. Shouldn't be any different, right at 0. Okay. But the first thing I want to be clear on before I do anything else is its period. And that's pi. All right, so now, had I gone out to pi, I would just see 1 period. I went out to 2 pi, and I should see 2. Remember, that's what B tells us. That's how many periods you're going to see in 2 pi. We have enough room to do 2. Okay? And so this is really the halfway point, so I know there the sine curve should be back to 0. So this first period would look way up to 3, back to 0, down to -3, and back to 0. Okay? There's number 1, and here's number 2, all the way up, back to 0 at 3 pi over 2, down to -3, and back up. Okay? That graph in green, again, is 3 sine of 2x.